You live right here, or here, or here, or somewhere on this sphere. Or well, actually somewhere on this oblate spheroid. Earth technically isn't a sphere because its spin flattens it out a little, but that's a topic for another video. This is the moon. A common misconception is that the moon orbits the Earth like this, but this is actually entirely false. The moon isn't anywhere near this close to Earth. If it were, a full moon would look something like this. Instead, the moon is actually over 363,000 kilometers away, at the closest point in its orbit. But because it has an elliptical orbit, its orbit can actually extend beyond 405,000 kilometers away. This is certainly far, but it's still really easy to lose reference here. So to put this gigantic distance into perspective a little more, you could fit every other planet in the solar system in between the Earth and the moon, including gigantic Jupiter. But what's more, you could also fit all of the 5 dwarf planets in the solar system in there too. And what's even more, there's still over 8,000 kilometers left. And what's even more is that you could fit the sun. Wait a minute. Actually, the sun just by itself can't fit between the Earth and the moon because the sun is over 1.3 million kilometers in diameter. But don't worry, this gigantic star will very, very quickly become complete. Wait, wrong video. Another misconception is this. This is not the solar system. This is the solar system. Okay, that's a bit ridiculous, but it's true. The reason the solar system is generally shown like this is because you can't really see anything if you illustrate the solar system like it actually is, because the distances are just so far. I mean, let's take the distance from the sun to the Earth, for example. If you could travel at the speed of light, you could travel from the sun to Earth in just about 8 minutes and 19 seconds. Now, for comparison, light can travel around the Earth in less than 1/7 of a second. Well, except it doesn't generally travel in a circle. But ignoring that, it can travel around the Earth 7.5 times in 1 second, which means that light could travel around the Earth over 3,700 times in the amount of time it takes light to travel from the sun to Earth. Now, that's great, but it's still nearly impossible to understand since it's still all numbers, which most humans have a difficult time fully comprehending. So let's use a different scale. Instead of 1 to 1, let's use a scale of 1 to 25 billion. At this scale, the Earth would be about the size of a grain of sand. Now, find a grain of sand and stick it on the tip of your finger. Then stick your arms out as straight as you can. Now, find someone else, actually you might want to do that first, and have them stand beside you with their arms straight out as well. Then find another person and have them do the same. Then find another person and have them do the same, but have them also balance a tomato on their head. And that is the Earth compared to the sun. Just 25 billion times smaller and maybe completely messed up depending on the size of your tomato and the arm span of each person. Now, Jupiter is the largest planet created in the solar system, but at this scale it would only be about the size of a pea. Oh, and its distance from the sun, well, this one's a bit harder to actually visualize in person because even 25 billion times smaller, it's still a pretty large distance. Take your tomato and throw it as far as you possibly can. And that is Jupiter compared to the sun. Although perhaps a better way to visualize this, unless you really dislike tomatoes, would be to set your tomato on the ground and then take the pea up onto the roof of a 10-story building. And that is Jupiter compared to the sun. Oh, and Jupiter's orbit velocity at this scale would be less than 2 millimeters per hour, or less than 2 inches per day. What's a little shocking is that pea-sized Saturn, even though it's just one planet over, is nearly double the distance from the sun, or about the height of an 18-story building. And at this scale, the thickness of Saturn's rings would be about the height of just 2 atoms, although the thickest portions of the rings could be nearly 200 atoms thick, which might sound big, but that's less than half the height of a coronavirus. Oh, and for reference, a person at this scale would be about 70 picometers tall. That's about the height of a single helium atom, which is the smallest atom we know of. If you stacked a bunch of these tiny people on top of each other, it would take over 7 million to stretch across a single grain of sand. It is rather shocking that at a scale so small, Neptune, the farthest major planet from the sun, would be over 179 meters from the tomato. That's nearly the height of the Space Needle. But this is not the edge of the solar system. Eris is the farthest dwarf planet from the Sun. At our 1 to 25 billion scale, Eris would be over 400 meters away from the tomato-sized Sun, just a little less than the height of the Empire State Building. But this is still not the edge of the solar system. Eris, Pluto, and many other trans-Neptunian objects lie in the Kuiper belt. This belt is estimated to extend nearly 1,000 times farther from the Sun than Earth's orbit. 25 billion times smaller, this massive distance would be about 6 kilometers away. That's farther than 7 Burj Khalifas stacked on top of each other. But this is still not the edge of the solar system. It is estimated that there are objects orbiting our Sun over 100,000 times farther from the Sun than Earth's orbit. At our scale of 1 to 25 billion, that places the edge of the solar system 600 kilometers away from our tomato. That's the distance from Berlin to Amsterdam. Remember, Earth is the size of a single grain of sand. Oh, and the size of the observable universe at this scale would be the distance all the way around the real world Earth over 878 million times, or about the real world distance from Earth to the second closest star, Proxima Centauri, or the real world distance from the Earth to the Sun and back over 100,000 times. It's just impossible to comprehend such a massive number, and yet Earth is still just a single grain